Hello everybody, welcome to Fun and Science channel. Don't forget to subscribe and like video. Today we will talk about IUPAC nomenclature of organic compounds. IUPAC means International Union of Pure and Applied Chemistry. IUPAC system of naming organic compounds. Let us start with the word root. It's the name corresponding to the number of carbon atoms in the longest chain of carbon atom in the organic compound. To determine the word root, we need to learn the table given alongside. 1 means meth, 2 means eth, 3 prop, 4 piot, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 tec, 11 yondec, 12 dodec. Now let us come to the primary suffix. If the compound contains only single bonds, it will be alkane, and the primary suffix will be ane. If the compound contains double bond, it will be alkene, and the primary suffix will be ene. If the compound contains triple bond, it will be alkyne, and the primary suffix will be yne. If the parent chain contains 2, 3 or more double or triple bonds, then the numerical prefixes such as di for 2, tri for 3, tetra for 4, and so on will be added to the primary suffix. But what if both double and triple bonds are present between carbon atoms? For example, CH triple bond C, CH2, CH2, CH double bond CH2. The name of this compound will be hex 1-ene 5-wine. Both ene and wine are written, but ene comes before wine. And the compound will end it with yne because it will be alkyne. But only ene take the lower number. Let us now concentrate on secondary suffix. For example, COH carboxylic acid, the suffix will be OIC. COOR ester, the suffix will be OATE. COX, while X may be fluorine, chlorine, bromine, or iodine. The compound is acyl halide, and the suffix will be OYL, halide. If we look to the table, we will see functional group and the suffix. Acylamide CONH2, the suffix will be amide. Nitrile CN, the suffix will be nitrile. Aldehydes CHO, the suffix will be AL. Ketones CO, the suffix ONE. Alcohol OH, the suffix will be OL. Amine NH2, the suffix will be amine. Alkene C double bond C, the suffix will be ENE, and alkyne C triple bond C, the suffix will be YNE. If we look to the example, CH3 CH2 CH2OH, the name of this compound will be propanol. Prop because it contains 3 carbon atoms. ENE because the compound is saturated. All carbon-carbon bonds are single bonds. OL because it contains OH group, so the compound is alcohol. Let us now come to what we call as prefix. These are also two types: primary prefix, secondary prefix. Primary prefixes like cyclo. The prefix cyclo is used for cyclic compound to distinguish between cyclic and acyclic compound. If we look to the example, we see cyclopentane. The difference between cyclopentane and normal pentane that normal pentane is open chain, while cyclopentane is cyclic chain. The prefixes of some functional groups: COOH, the prefix is carboxy; SO3H, sulfo; COOR, alkoxycarbonide; COCl, haloformyl; CONH2, carbomyl; CN, cyano; CHO, formyl; C double bond O, keto or oxo; OH, hydroxy; SH, mercapto; NH2, amino. Secondary prefix. Certain groups in organic chemistry are written as prefixes. They are regarded as substituents. These groups, along with their prefixes, are as follows. F is fluoro, Cl is chloro, Br is bromo, I is iodo. NO2 is nitro, NO is nitroso, N double bond N, diazo, OCH3, mesoxy, OC2H5, isoxy, OH, hydroxo, NH2, amino. For example, 2-chloroputane. Note that the word root will come after the prefixes. Different classes of organic compound. Hydrocarbon. Saturated hydrocarbon. Number 1, alkanes. General formula is CnH2n plus 2. Suffix ANE. These are the organic compounds which contain only carbon-carbon single bonds. According to IUPAC system, these are named as alkanes. For example, methane, ethane, propane, butane, pentane, hexane. 2. Alkyl groups. General formula of alkyl groups is CnH2n plus 1. Suffix YL. Alkyl group contains only one H atom less than the alkane. The alkyl group is named by substituting the suffix ANE of the name of the corresponding alkane by YL. For example, methane becomes methyl. Important alkyl groups: methyl CH3, ethyl CH3CH2, propyl CH3CH2CH2, isopropyl CH3CHCH3, butyl CH3CH2CH2. Tertiary butyl is different than butyl in the branching only. Unsaturated hydrocarbons, they are classified into two types, alkene and alkynes. Alkenes, general formula is CnH2n, suffix is ENE. The molecules containing one carbon-carbon double bonds are called alkenes. In IUPAC system, the name of alkenes is derived by replacing suffix ENE of the corresponding alkane by ENE. For example, 2 carbon in alkanes mean ethane, but in alkenes mean ethene. Some alkenes group: CH2 double bonds H2, ethylene; CH2 double bond CH3 propylene, and so on. Some alkyne group CH triple bond CH is called acetylene, CH triple bond CH3 propene, and so on. We can alkyl halides. The general formula of alkyl halides is CnH2n plus 1 X or Rx, which are mean alkyl group. The prefix is halo. These are obtained from alkenes by the replacement of one or more hydrogen atom by halogen atom. We convert from RH to Rx, where X is halogen, fluorine, chlorine, bromine, or iodine. In the IUPAC system, they are named as halogen substituted alkanes or haloalkanes. Thus, the name of halogen compound is given by prefixing fluoro, chloro, bromo, iodo to the names of the alkane. For example, CH3Cl is called chloromethane, CH3CH2Cl is called chloroethane, and so on. Alcohols. General formula CnH2n plus 1 OH or ROH, where R is alkyl group. The functional group of alcohols is OH, and the suffix is OL. These are derived by replacing one hydrogen atom from an alkane by one hydroxyl group. In IUPAC system, these are called alkanols, and their names have been derived by changing E of corresponding alkane by OL. We convert alkane to alkanol. Some alkane and their alcohols, for example, CH3CH3 ethane will be ethanol CH3CH2OH. Propan CH3CH2CH3 will be CH3CH2CH2OH propanol. Also, CH3CH2CH2CH3 butane will be butanol. Ethers. General formula is CnH2n plus 1 or CmH2m plus 1. Between them, we will find oxygen. The functional group is oxygen. So, the general formula of ethers will be CmH2m plus 1 or CnH2n plus 1. For example, CH3OCH3 will be called methoxymethane. Aldehydes. The general formula CnH2nCHO. Functional group will be CHO, and suffix will be Al, like we said before. These compounds are obtained by replacing hydrogen atom attached to the terminal carbon atom in alkane molecules by an aldehydic group CHO. The first member is, however, obtained by replacing a hydrogen atom in the hydrogen molecules. These are called alkanals in IUPAC system of nomenclature, and the names of individual members are derived by changing E of corresponding alkane by Al. Some examples of aldehydes: HCHO formaldehyde, CH3CHO acetaldehyde, and so on. Ketones. General formula is CnH2n plus 1, COCmH2m plus 1. The functional group is C double bond O, and the suffix is ONE. These are obtained by replacing two hydrogen atoms attached to the non-terminal carbon atom in alkane's molecule by a divalent oxygen atom. Thus, the functional group called ketonic group contains a carbon atom joined to the oxygen atom by double bond. The names of individual members are derived by replacing E of the corresponding alkane by ONE. Alkane will be alkano. Carboxylic acid. General formula is CnH2n plus 1 COOH. The functional group is COOH, and the suffix will be OIC. In these compounds, one hydrogen atom in alkane molecule is replaced by a carboxyl group, COOH. The first member is, however, obtained by replacing a hydrogen atom in the hydrogen molecule. In the IUPAC system, they are named by replacing the terminal E of corresponding alkane by OIC acid. Alkane will be alkanoic acid. Amines. General formula is CnH2n plus 1 NH2. The functional group is NH2 and the suffix will be amine. These are the alkyl derivatives of ammonia. They are formed by replacing 1, 2, or all the 3 hydrogen atoms in ammonia with alkyl radicals. In IUPAC, the name is derived by replacing E of alkane by amine. Alkane will be alkanamine. For example, CH3NH2 is called methylamine. CH3NH, dimethylamine. CH3N, is called trimethylamine, and so on. Rules for naming an organic compound. Longest chain rule. Determine the longest chain, not necessarily straight. It may be changed or branched. The long chain here is CH3, CH2, 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 CH, CH3. And the branch is alkyl group. Number 2. Position of the substituent. Number of the carbon atom in the parent chain as 1, 2, 3, and so on, starting from the end, which gives lower number of the carbon atom carrying the substituent. Always number from the end of longest chain closest to the first branch. For example, if you look to right, this is correct. X on carbon number 2. But on the left, if we begin to number carbon atom from left, it will be wrong, because X will be number 4. We choose the lower number of substituent. 3. Lowest set of locant rule. When 2 or more substituents are present, then end of the parent chain will give the lowest set of locants is preferred for numerical. Number the chain so as to give the lowest number possible to the functional group, followed by double bond, triple bond, and finally the substituent. Consider an example: COOH, CH double bond CH, CH2, CH2Cl. We will begin to numeric from first carbon in carboxyl, or from first carbon on the right. So, which one is the correct numbering according to the above rule? From carboxyl or from carbon which carry chlorine? If you note in the above example, in set 1, the functional group is COOH, and it has a carbon in it. In such cases, the carbon of the functional group always gets the position number 1. What if the same functional group exists twice in the chain? For example, CH2OH, CH2, CH2, CH2OH. Here, irrespective of the end you start from, you get the same position number both away. Please be careful not to number the oxygen in the functional group. You only have to number the carbon atoms in the chain. Hence, the compound is butane 1,4-diol. But it is the word root, and it is the primary suffix. 1,4 is locant, diol is secondary suffix. Note, the position number of each of the functional group is expressed by the position number of carbon atom to which it's attached, and it's known as locant. The locant are separated from each other by comma. The locant and the words are separated by a hyphen. The numerical prefixes di, tri, tetra, and so on are used to indicate the presence of 2, 3, or more like groups. Let us try naming the compound which we had taken as an example. COH, CH, double bond CH, CH2, CH2, Cl. If we use the rule we said, the name will be 5-chloropent-2-ene-1-oic acid. And the right numerical from carboxyl, not from CH2 which carrying chlorine, because COOH is a functional group of the compound. What if different substituents are present in equivalent position? For example, CH3CH2, CH2H5, CHCH3, CH2CH3. What do you think would be the correct answer? A. 3-ethyl-4-methylhexane, or B. 4-ethyl-3-methylhexane. When confused about substituents, always remember that we consider the alphabetical order. Hence, option A is correct, but ignore multiplying prefixes, di, tri, and so on, while considering the alphabetical order. Rules for naming compounds having more than one functional groups, or substituent, or multiply bond. In a class of students, one student is elected as leader while the other are to follow. Similarly, when more than one functional groups are present, one functional group is chosen as the principal functional group, written as suffix, while others are regarded as substituent, written as prefixes. Now, how do we decide the principal functional group? To remove any confusion, the functional group are arranged in a prefixes series as follows: carboxylic acid, then sulfonilic acid, then anhydride, then ester, then acid chloride, then acid amide, then nitrile, then aldehyde, then ketone, then alcohols, then amines, then alkene, then alkyne. The group higher in the preference series is written as a suffix, while the one lower to it would be written as a prefix. The corresponding prefix and suffixes are given areal for each functional group can be complied as follows. Finally, don't forget to subscribe and share the video if you like it, and wait to see another video soon. Bye bye.